Oxidation numbers. The oxidation number or oxidation state of an element is defined as the possible electronic charge which the atom of the element appears to have acquired in the given chemical form of the element. The common oxidation states of the elements are related to their valency electronic configuration. Variation in a group. The oxidation number of the elements is mostly equal to the group number. It varies from group to group. For S-block elements, the maximum positive oxidation state shown by any element is equal to the total number of valency electrons. Example, group first A, valency electronic configuration NS1, valency electrons 1, oxidation number +1. 2A group, valency electronic configuration NS2, valency electrons 2, oxidation number +2. P-block elements exhibits various oxidation states. These elements often gain or lose sufficient number of electrons in order to attain noble gas electronic configuration. Group 3rd A, general electronic configuration NS2NP1, valency electrons 3, oxidation number +3. Group 4A, general electronic configuration NS2NP2, valency electrons 4, oxidation number +4. Group 5A, general electronic configuration NS2NP3, valency electrons 5, oxidation number -3 +3 +5. Group 6A, general electronic configuration NS2NP4, valency electrons 6, oxidation number -2 +2 +4 +6. Group 7A, general electronic configuration NS2NP5, valency electron 7, oxidation number -1 +1 +3 +5 +7. Group 8A, electronic configuration NS2NP6, valency electrons 8, no oxidation number. D-block elements exhibits more than one oxidation state. The outermost electronic configuration of D-block element is Ns1-2 n-1 d power 1-10. They show the common oxidation state of +2 due to the loss of Ns2 electrons. Ruthenium and osmium exhibit a maximum oxidation state of +8 in ruthenium oxide and osmium oxide respectively. Oxidation states of transition metals. Elements scandium, oxidation state +2 +3. Titanium +2 +3 +4. Vanadium +2 +3 +4 +5. Chromium +2 +3 +4 +5 +6. Manganese +2 +3 +4 +5 +6 +7. Iron +2 +3 +4 +5 +6 +7. Cobalt +2 +3 +4. Nickel +2 +3 +4. Copper +1 +2. Zinc +2. Determination of oxidation number. Rule 1. The sum of oxidation numbers of all the atoms in the molecule is equal to 0. Example in potassium permanganate KMnO4. Oxidation number of K plus oxidation number of Mn plus 4. Oxidation number of oxygen equal to 0. Rule 2. The oxidation number of an atom in its elementary form is always 0. Example, the oxidation number of hydrogen, oxygen, nitrogen, phosphorus, sulfur, cesium, copper, silver in their elementary forms, that is H2, O2, N2, P4, S8, Se8, Cu, Ag respectively is 0. Rule 3. The oxidation number of alkali metals lithium, sodium, potassium, rubidium, cesium in their compounds is always +1. Examples in sodium chloride, the oxidation number of sodium is +1. Rule 4. the oxidation number of alkaline earth metal, beryllium, magnesium, calcium, strontium, barium in their compounds is always plus 2. Example, the oxidation number of magnesium in MgO is plus 2. Rule 5. The oxidation number of hydrogen in its compound is always plus 1 except in metal hydrides. Example, in hydrochloric acid, the oxidation number of hydrogen is plus 1. In sodium hydride, the oxidation number of hydrogen is minus 1. Rule 6. The oxidation number of fluorine in all of its compound is minus 1. Example, in sodium fluoride, the oxidation number of fluorine is minus 1. Rule 7. The oxidation number of oxygen in most of its oxide is minus 2 except in peroxide, superoxide, oxyfluorides and ozonides. Example, in sodium oxide, the oxidation number of oxygen is minus 2. In magnesium oxide, the oxidation number of oxygen is minus 2. The exceptional cases. Case 1. Peroxide O2 2 minus. Two oxygen atoms are bonded by a single bond OO twice or O minus O minus. The oxidation number of each oxygen in peroxide ion is minus 1. Example, the oxidation number of oxygen in hydrogen peroxide is minus 1. The oxidation number of oxygen in sodium peroxide is minus 1. Case 2. Superoxides O2 minus 1. The oxidation number of each oxygen in superoxide is minus 1 by 2. Example, KO2. Case 3. Oxyfluorides. Oxygen plus fluorine gives to oxyfluorides. Dioxide difluoride, oxygen difluoride. O2F2 and OF2. In O2F2, the oxidation number of oxygen is calculated as follows. Let X be the oxidation number of each oxygen atom. 2x plus 2 into minus 1 equal to 0. 2x equal to plus 2. X is equal to plus 1. So the oxidation number of oxygen in O2F2 is plus 1. In OF2, the oxidation number of oxygen is plus 2. Case 4. Ozonides O3. The oxidation number of each oxygen atom in ozonides is minus 1 by 3. Calculations. Let X be the oxidation number of each oxygen atom. 3 into X equal to minus 1. Minus 1 by 3. Example, KO3. Rule 8. In a compound ion, the sum of the oxidation states of all atoms is equal to its charge. Example, in SO4 2 minus, the oxidation number of sulfur plus 6, oxidation number of oxygen minus 2. Rule 9. The maximum oxidation number of any element is equal to its group number except in the case of oxygen and fluorine. Example, the oxidation number of sulfur in H2S2O8, K2S2O8, S2O8 2 minus and H2SO5 is plus 6 due to the presence of peroxy bond. Rule 10. In some compounds, all the atoms of the same element may not have the same oxidation number. When we calculate the oxidation number for the element in such compounds, we get the average value. Example, in Na2S2O3, the oxidation number of one sulfur atom is plus 6 and that of other sulfur atom is minus 2. So the average oxidation state of sulfur in Na2S2O3 is plus 2. In CaOCl2, the oxidation number of one chlorine is minus 1 and the other chlorine is plus 1. So the average oxidation number of chlorine is 0. Structure of CaOCl2 and Na2S2O3 is here. Rule 11. In organic compounds, carbon can have any oxidation number from minus 4 to plus 4. Example, in HCHO, the oxidation number of carbon is 0. Rule 12. From first A to fourth A group, the common oxidation number of an element is equal to its group number. From fifth A group to eighth A, the common oxidation number of any element is given by the formula. Example, oxidation number of first A group element plus 1. Oxidation number of second A group element plus 2. Oxidation number of third A group elements plus 3. Oxidation number of fourth A group elements plus 4. Oxidation number of fifth A group elements minus 3. Oxidation number of sixth A group element minus 2. Oxidation number of 7A group element minus 1. Oxidation number of 8th A group elements 0. Rule 13. In all carbides, nitrides, phosphides, sulfides, the oxidation number of carbon, nitrogen, phosphorus, sulfur are minus 4, minus 3, minus 3 and minus 2 respectively. In Mg3N2, the oxidation number of nitrogen is minus 3. In SiC, the oxidation number of carbon is minus 4. In Ca3P2, the oxidation number of phosphorus is minus 3. In H2S, the oxidation number of sulfur is minus 2. Rule 14. The oxidation number of metal in all metal carbonyl is 0. Example, nickel carbonyl, the oxidation number of nickel is 0. Note, in NCl3, the oxidation number of N is minus 3 and Cl is plus 1 because nitrogen is smaller in size than components chlorine. Oxidation number is also defined as a number which indicates the loss or gain or sharing of electrons by an atom during the formation of a chemical compound. Oxidation number can have positive, negative or zero values depending upon the state of combination in the compound or ion. Example, hydrochloric acid HCl, H plus Cl minus. Oxidation number of hydrogen is plus 1 and oxidation number of chlorine is minus 1. Similarly, in carbon tetrachloride CCl4, oxidation number of each Cl is minus 1 and that of carbon is plus 4.